Alright guys, so this is the last video for the chapter 1 through 3 review, okay, at least what I went over in class. And so this one right here, this is a big one. And again guys, if you don't remember everything here, you should be able to do the first parts, okay? And so here, this right here, the first part is asking to find the potential zeros. Okay, so here guys, I have to find potential zero. So I'm going to look at P over here and Q. Okay, so here my P is equal to 18. So we're not going to take into account the negative. So it's just 18, and my Q here is a 1. So I want my factor sum of P and Q. So here, plus or minus 1, plus or minus 18, plus or minus 3, and plus or minus 6, and plus or minus 2 and 9. So those are all my factors of 18, because if I multiply these two numbers, they give me 18. And on the bottom, it's just 1. So my list of possible zeros is plus or minus 1, plus or minus 18, plus or minus 3, plus or minus 6, plus or minus 2, plus or minus 9. Okay, so that's my full list. And this will be a calculator problem, luckily. So some of this work you won't have to deal with, okay? And so I went ahead and graphed this thing. Okay, so this is the equation. Okay, you can see the equation right here. And I went ahead and plugged it into the calculator. Next part is asking us to use synthetic division to find the rational zeros. So find the actual zeros, where 0 is where I cross the x-axis. So if I did not have the calculator, if I did not have the graph like I see right here, this would take a very long time to do. And so I'm going to go ahead and look at the graph here. I crossed at 1, 2, 3, 4, 5, excuse me, negative 6. So I'm going to start with my negative 6 here. Okay, so I already know I crossed at negative 6, so I'm going to do synthetic division with this right here. So my first value here is a 1. My cubed term is a 3. My squared term is a negative 17. My linear term is a 3 also, positive 3, and the constant's negative 18. So what I'm looking for is a remainder of 0. Again, this comes down, so 1 times negative 6 is negative 6. And then I add down, so 3 minus 6 is negative 3. Negative 3 times a negative 6 is a positive 18. And negative 7 plus 18 is 1. 1 times negative 6 is negative 6, and 3 minus 6 is negative 3. Negative 6 times 6, negative 3 times negative 6, positive 18. I get a remainder of 0, which is what I was expecting because I saw the graph already. Okay, so what I've done right here, guys, is I'm going to start to put this in linear terms. So remember, you switch the sign here. This was a negative 6. When I'm writing the linear term, it's x plus 6. This is x cubed now, so this goes 1 power less. Minus 3x squared plus x minus 3. Okay, so again guys, I did use the calculator, and we did see actually in the calculator that was not the only place it crossed the x-axis. It also crossed at 1, 2, at 3. So I'm going to go ahead and continue this problem. So I'm going to use this now as my basis. So the 1, negative 3, positive 1, and negative 3. Okay, again, I got these values from here. And now I'm going to divide by positive 3, because that's where I crossed the x-axis at positive 3. So again, I should expect a remainder of 0. So I'm going to go ahead and do the math here. So 1 times 3 is 3. Negative 3 plus 3 is 0. 0 times 3 is 0. 1 plus 0 is 1, and 1 times positive 3 is positive 3, and again here I ended up with a remainder of 0. Okay, so what I've done here is I've continued to factor, and so I would continue to factor this piece. So I have the x plus 6 already that I already factored out, and now I'm going to continue. So I factored out a positive 3, so I have to put a negative, and then the rest of this is just x squared, right, because this is an x, and then plus 1. Okay, so this right here is my factored form. Okay, and I don't want you to get confused, because right here I'm going to move down. Express this as a linear and irreducible quadratic factor. Since we saw in the graph that it doesn't cross the x-axis anymore. Okay, so I can't get lower. I can't reduce this part anymore, so it's just going to stay like that. So right here, my answer for the reduced form is exactly what I just finished writing, so it's not going to change. Okay. I'm sorry, plus 1, not minus 1. Okay, so that's that. And if I move up here, identify the complex zeros. Well, if I were to factor this part right here, okay, this little piece right here, I'm going to see that I'm going to end up with something that I cannot have. And so this will be minus 1 to get rid of it over here. Again, I'm just solving for x. And if I square root it, I get x is equal to the square root of negative 1. Now, that's not a possibility. Excuse me, this should be plus or minus. Not a possibility, but I do know that the square root of negative 1 is equal to, oops, shouldn't equal sign, I. So these are the complex zeros, at least. So that's what I can reduce this piece to. Okay. And the last thing over here is if the function defined by f of x is x minus 3x plus 6, then find g of f of x and give its domain. So here it's telling me to divide g and f. Okay, so guys, I would use the factored form since we already have it here. So it's x plus 6, x minus 3, and x squared plus 1. And I'm dividing by this new equation f that they're telling me, so x minus 3 and x plus 6. So what I'm going to see here is that these will cancel. Okay, they will cancel. And remember, when I cancel something on the top and on the bottom, that creates a whole. So when I divide this, all I'm left with is x squared plus 1. But since I created holes here at x minus 3 equals 0, which means I have a hole at x equals 3, and x plus 6 equals 0, so at negative 6 I also have a hole. So my domain here would be from negative infinity to negative 6, and then negative 6 to positive 3, and then 3 to infinity. Okay, so long problem, kind of hard one. Again, we should at least be able to do the first parts. Okay, possible zeros, this is easy. You better not get that wrong. And here we can use the graph to continue to factor this thing. So that's it for right now. And look for the other video, guys, for the review for Unit 4 through 6, and just some supplemental ones for some of the harder problems.